Okay.
Yeah.
Thanks everybody for coming to the dissertation defense called. Well, let's move the people up here. Let's see. Yeah, focused and panoramic perspectives on the future of work. With my committee, I'll move this screen share bar. Alicia Modestino, my chair, Brooke Foucault-Wells, and we got Rich Radke. He's out at RPI, my external faculty, and then we have Shuo Zhang in the economics department at Northeastern. Oh, I should double check. Could someone on the Zoom say if you're seeing my screen right now?
We can see it, Sam.
Yep.
Perfect. Okay.
Oh, wait a second. All I see is I don't see any slides yet. I saw them before, but now I don't.
You don't see, so I got a slide up that says why.
Slide. I see your face. Maybe there's a different way of doing this.
We have it, Sam.
Yeah. So we'll wait for Rich. He's important.
Does anyone else see it? Hello, can you see what's going on?
All I see is a large screen of your face, Sam.
Okay, we'll try. We'll screen share again. Let's see.
There we go. Yes, I see that. Thank you.
Perfect. Okay, so let's start with the why of this presentation. I'm gonna move this a little. So obviously AI is transforming everything. It's been on all over the news. I'm sure most of you have used it at this point. And even before all the generative AI stuff, it's led to some pretty cool transformations where humans are working with AI. We can use AI to change our work and make us more productive, more creative. So we're going to go and dive into that and talk about the disruptions and opportunities that have been created through this human-machine collaboration. So some key questions we'll cover with each chapter. We'll go through an example of human AI collaboration. And we built basically a team performance example to pilot what's possible and what we possibly can do once technology advances. Talk about different ways to design an AI teammate and different choices that you can make when you're choosing a voice or choosing the helpfulness. And then look at the broad impact of this new technology. So looking at the macroeconomic effects of AI. Start with chapter 1. Let's move this bar even higher. Okay, chapter 1. So this is collective intelligence in human AI teams, joint work with Chris Riedel, and it is published in the AAAI conference proceedings. Oops. Okay, there we go. So this all hinges on a topic called theory of mind, where we're basically right here, this character is thinking of a triangle. And their partner is thinking that they're thinking of a triangle. That's great. That means they're both on the same page, they're on the same topic, and there's no misunderstanding. Now, say this character is instead thinking of a square. They're not on the same page anymore. Theory of mind has collapsed, and they're just not, there's going to be misunderstandings. It's going to lead to lower performance and also just less satisfaction among members of the team. So in this paper, we're going to build on top of the concept of theory of mind to make an AI teammate in an application. And so we're going to model team members' beliefs, and then we're going to model team members' beliefs of their teammates' beliefs. And when there are differences in those models, that's when we bring them together and we're like, there's a misunderstanding here. Let's try to fix that. Let's reduce that. Let's get back on the same page. So the setup. We collected this data back in 2017, before my time, on volunteer science. So shout out to Jason and that team who's doing volunteer science stuff. 29 teams of 5 people, and they're playing this hidden profile game. Basically, with the hidden profile game, it's like Clue, if you've ever played Clue, where every player gets some clues, and you have to bring them together to find whoever like stole the art painting in this case. For the hidden profile game specifically, it's every player has one clue that's unique to them, and then everybody's sharing a clue as well, but you don't know what's what. So the way to solve this game every time is if you just share all your information, you're going to get it every time. But the thing is, people don't share it all the time. And in addition, to make it a little harder, we randomize the communication network. So if you look at this case, player 1 can only talk to player 4, 5, 3, and 2, but 4 only talks to player 1. 5 only talks to player 1. And that's going to be important later on. So here's an example of actual chats that happened. Basically, the humans all had their clues, and they're trying to find out what day it happened. It could be Monday through Friday, not Saturday or Sunday. So if we're gonna read through this, we're gonna figure out what the answer is together. It will not happen on Tuesday. It won't happen on Wednesday or Friday. It could be Monday or Thursday, but it might not be Thursday. Yeah, and it's not Thursday. It's not Thursday. So that it's not Tuesday, Wednesday, Thursday, or Friday. It must be Monday. And that's what the communication looks like. So then the answer, the heist happened on Monday, and get that correct. Now, what are the mechanics? It's basically Bayesian inference, what we're doing here. Player one, let's just say player one is trying to figure out what player three believes. And when player three says it might be Thursday, then underneath the hood, we're going to update our estimate of what player three thinks. So here, we don't need to get into the crazy details of it, but player one has a model of player three. And right now it's pretty even. Like it could be any answer, any of the 5 answers. This is a probability distribution, the posterior. And then when player three says it might be number 4, then boom, it skyrockets up and it's clearly going to be number 4. That's what player three thinks. So that's the type of model we're doing. Breaking into the equation a little bit, we just have vanilla Bayesian inference, but then we add this extra term right here. And so what that term does is it shoves the opinions to either side. If it's a pretty surprising result that's far off from what's expected, normally that wouldn't have as much updating influence, but we want that influence to be high. If it's surprising, if people are saying stuff that's very different than what we think they think, we want to make a larger update. And so that's what that term is doing right there. So here's like breaking down a little example. In this case, it's a 4-player thing. Our actual thing is 5 players, but we'll just go. This is a nice little graphic I found that only had 4, so we'll work with that. So in this case, we have an agent modeling this person, and then also another agent modeling what this person thinks player 2 thinks, and then what they think player 3 thinks. So in total, if we have 5 players, we're going to have 5 agents for each player. That's going to be 25 agents total. And so they've learned these distributions of what the players might answer. And we need to aggregate all these distributions together to get a final estimate for how they're going to respond. So first, this is the model of just the player themselves. And then this is the model of what the player thinks all their teammates think. So we aggregate all that, but then we aggregate that using this little theory of mind parameter. So how much influence do other people's beliefs actually have on your own belief? Yeah, a lower alpha here, less influence, higher alpha, more influence. And what do we find when we do a model like that? So the actual performance of people playing this game was about 66% correct. And so that's just aggregated over individual answers, not team answers. And so we have some baseline models for comparison, and we get down to max performance and max agreement. Those are 2 different things that we tried to optimize for. With max performance, we have an alpha really high of 0.95, and we end up just based off of the conversations alone, we can estimate the correct answer 77% of the time, which is higher than the human 66%. But then lowering the influence of other people's belief, lowering the alpha, we can get a human agent agreement. So in this case, we can predict what the human will respond. It might not be the actual right answer, but we're like, oh, this person's definitely going to answer number 4, which is also valuable. And we can get that up to 78% accuracy. So now the big application, the interesting thing to me is intervening to reduce misunderstandings, because that's easily the most frustrating part about working with people. And this is a simulated counterfactual intervention where basically we let agents say another message. They can say one more thing to people to try to sway them to one belief or another belief. And we're trying to converge beliefs. So the way to do this, we have right here, we have the individual's posterior distribution, and then what they think the other agents think at the very end. And we're just going to pick one message that was said during the game, like maybe it is Thursday, and just repeat that information between these 2 people. And we're like, hey, you should talk a little more. You should say one more thing and reconverge to try to hit the right answer. So that's what we do. We just add this little extra step of intervention. And what do we find? So obviously we pick the best message in that case, but if we were to pick a random message just to keep converging on a belief, random message brings it up from 77% performance to 79% performance. And then we can also target the intervention. So this is targeted, this is not random. And with a targeted intervention, we bring the performance up to 82%, showing that just a little bit of intervention, a little bit of correction can go a long way for helping the team perform better. So some implications. We've shown how theory of mind can be helpful in a human AI team setting. So building an AI structure with the concept of you want to know what you are thinking, your teammates are thinking. That's helpful for building a human AI team. And this also lays the groundwork for applications for misunderstanding resolution. You could think you're on a Zoom meeting, and the applications are starting to come out now. So this was published a few years ago. And I don't know if you've been on meetings where it's like, there's some disagreement between these people. And it's a little annoying to see actually. So in the next chapter, we'll talk about usability or perceptions of the AI assistant, because that's super important. But these applications are already starting to come out where you can estimate misunderstandings between people. Limitations, it was a stylized intervention, it was simulated. And then participants might have been unmotivated because it's Amazon Turk. I don't know if you've done any research on Turk, but sometimes they're just there to get their like 50 cents or something. And that could change the human performance in the end. Okay, chapter 2. So this is joint work with Rich Radke, Chris Riedel, and then also Brooke Foucault-Wells. We are working on perceptions of agents within human AI teams. And this was published in Computers and Human Behavior, Artificial Humans. If you came to my proposal, I'll move this a little bit for you guys again. If you came to my proposal, then we did this, but we did this with a different curse. So basically, this is the game we put participants through in teams. And in the proposal, I had people try to figure out the octopus curse, but now let's try to figure out the dual curse. So treasure chest or gems in each treasure chest, and something to do with the gems gives people a certain curse. That's like it gives the gem a certain curse. If you participated in this, I know some of you participated. Don't spoil it, but yeah, if you figure out the answer, just interrupt me. I'm going to keep it up on the next few slides, so you can tell me why a dual curse is given to one chest but not a different chest. Okay. Some background. The goal here is to understand mechanisms between human agent interaction. We know that like humans can trust human voices more than robotic voices. We also know that perceived anthropomorphism, which is attributing human traits to non-human entities, that depends on an agent's contribution. And this all, did I get them all? Then all depends on this paradigm. We're interpreting it through this paradigm called the computers or social actors paradigm. So to sum up the computers or social actors paradigm, we operate with a set of social scripts, just with everything we do. You go in order, you follow the script, you're driving, you're kind of following a script of what's acceptable, and different things can trigger different scripts. So if I were to show you two turtles, if I come across this turtle, I'm not going to expect it to be doing anything human-like. I'm not going to expect it to say like anything, any words, any English, like wear clothes. I don't expect anything from that. But then if you go over into some very lifelike Teenage Mutant Ninja Turtles, I'm going to expect them to follow a more human-like script. They're not just a random turtle walking through the swamp. Instead, they're very human-like, and that's how I would expect it. And so things like appearance can trigger expectations of behavior. And that's what the computers or social actors paradigm is all about. Okay. Has anyone up? Oh,
Single set of 3 gems where one is different than the others by color or size.
that is not correct. Okay, and so to go back a bunch of slides. Whoops, I'm going the wrong way. Spoilers. So I said it relates to the color of the gems. That was actually a misleading curse, a misleading clue. Wait. Okay, I think I found the right slide. So the actual clue is that it relates to the symmetry of the gems. Can anyone tell me? Yeah, so vertically symmetrical or whatever. Yeah, it's symmetrical this way, like a book. And so this is what we put people through. We either give them helpful clues or unhelpful clues, and then we also have them get those clues with a human voice or a robotic voice. And then we measure things like perceived anthropomorphism, which is attributing human traits to non-human objects. Animacy is also there's like life acting, like it's not being controlled by someone else, it is controlling itself. And then perceived intelligence, perceived trustworthiness, and we also look at overall team performance. They have 40 minutes to do this puzzle, teams of 3 or 4 on Zoom. And we end up with 5 teams in each category, teams of 3 or 4, just depending on who showed up, because scheduling undergrads to show up to things is a little unreliable. But it looks like late undergrad was our average age. So what do we find? Oddly, human was not rated as the highest anthropomorphism. So basically, these 2 measures, A and B, are measures of perceived humanness. And the most human, what was rated as most human, was the helpful robot voice, which is counterintuitive. This is and it's not linear at all. So it's helpful robot, unhelpful human, and then helpful human, and finally unhelpful robot, which is odd. We think that's pretty odd. But looking through the computers are social actors paradigm, we can kind of interpret this as the agent has triggered different social scripts and expectations. And when it violates that, like if it's a robotic voice, I'm gonna expect it to act differently than when it's a human voice. And so when it violates that, it's gonna seem less human. And also perceived intelligence. This is also in the same questionnaire series. Thankfully, this difference right here, not significant. So voice did not change ratings of perceived intelligence. It was just whether it was actually helpful or unhelpful, which is good because we want that to be an unbiased measure where I don't want to be seen as more intelligent because I put a brain on the screen, for example, like just random things. I want to be seen as intelligence because I'm actually saying things that make sense and are clear. Although there are some human biases, like this little citation down here. So now just because I put a brain on a slide, I didn't even do anything brain related. In the end, you will rate my presentation as just a little bit smarter. But in this case, the helpful versus unhelpful, an agent's contribution quality outweighed any bias that comes from a more physical attribute like voice. We also do perceived trustworthiness, which is also good to see that helpful, unhelpful is the only thing that actually affects trustworthiness. I don't want to be swayed if it's just their physical attributes like voice or how they look. I don't want that to sway somebody's trustworthiness. I want them to be trustworthy because of the actions they've actually taken. We do see there in human AI literature that voice can sway trustworthiness, attributes can sway trustworthiness, but a lot of those are just one-off. They're not interacting with the agent over a long period of time. They don't have any stake. So that's the explanation here, why we see results that disagree with what that literature says, because their contribution really outweighs just physical voice or physical attributes when thinking about if it's trustworthy or not. And these little dots here, you see there are some pretty big outliers. Some teams just didn't get the puzzle at all. They maybe got 1 milestone, maybe 2 over the 40 minutes. And so that's the explanation for these here. They just didn't really figure out that the agent was actually unhelpful. They were just pretty stuck for the whole thing. Okay, some performance results. Did we sway performance? And we only swayed performance with the clues that were given. Voice, again, you weren't more susceptible to accept suggestions from a human or a robot. Instead, it was just whether or not helpful or unhelpful clues. And there's probably a situation where it's a more sensitive difference between the voice and the helpfulness that could sway performance. But in our case, it was not sensitive to voice. This difference at 30 minutes, that's significant. a significant reduction between the helpful versus unhelpful treatments. At 40 minutes, they caught up. The unhelpful team, they caught up. They started answering more, so this difference is not significant. But we can say that the treatment was semi-effective at swaying the overall performance between the two groups. And the explanation here, why they caught up after the 40-minute mark, is at about 30 minutes. I was watching all of these, and at about 30 minutes, they're like, these clues don't make any sense, guys. And that let them go back, get rid of all the dead ends from the past clues they had gotten, ignore them, and catch back up with some big swings. So here are the results. I've been talking about significant, not significant. How am I actually claiming that? So we do two different regressions. One is on the perceptual measures, and then the team performance. So you can see that the interaction is in the perceptual measures, but not the team performance side. Going back, there's going to be no interaction between the voice and the helpfulness in performance. We see that, and it's not significant when we run the regression with it, so we just drop it. But it is significant for our questionnaire measures, at least for anthropomorphism and animacy, not for intelligence or trust, which is what we'd like to see. Okay, some implications that we see here. So perception, it's not just one-off things. You can't just take human and it's going to be a little, if it's always a human voice, it's not always going to be a little supplemented. Human can interact with other factors to swap perceptions of humanness, basically flip the effect of contribution on perceptions of humanness. And so designers and practitioners should be aware of that, because if you want to be seen as human-like, which can also make you seem more trustworthy, you should be aware of how you design the agent might have counterintuitive impacts on the actual user. And thankfully, trust and perceived intelligence are unbiased. Limitations of this, the agent didn't truly have autonomy. So if I'm saying human agent teams, human AI teams, usually that means a human with an agent together, but they both can work autonomously toward a shared goal. And in this case, our agent was not. It was just automated. And then in-person interaction, this was all over Zoom. So maybe if a team were all in person and they had a little agent with them, it could change the results as well. And I'd be curious to measure usability or likability next. They were forced to use it. They didn't have an option whether they could use it or not. And that's going to be an interesting factor where going back to that Zoom bot example that I was talking about, where there are existing applications to identify issues or summarize conversation, I get really annoyed by those, and that's going to lower the usability of them. So measuring usability or likability and factors that affect that would be an interesting route to take. Okay. Let's now move on to chapter 3. So we've been very zoomed in. We've been building little things, and let's zoom out to see how AI is not impacting just the team, but it's impacting the economy and the labor market in general. And so we're going to dive in just specifically with software developers because they've been hit pretty hard. And this is in collaboration with Alicia Modestino. Quick summary on what generative AI is. Underneath the hood, we have this technology that came about and popularized in 2017 called the transformer model. And it just expanded our capacity to store information in a machine and recall it and learn different patterns and just look really, really, really complex patterns and store them all. Transformers are cool, but if you used GPT-2, like in 2018, 2019, it could just repeat patterns really well. It wasn't a chatbot like OpenAI presents. And the way they created this amazing chatbot system is with reinforcement learning with human feedback. So that's like the cherry on top at the end of ChatGPT and all the GPT models, where their base of knowledge comes from this big transformer. And then they're using a little model right at the end to kind of make it a human enjoyable format. Okay. So a little bit about generative AI with software developers. There's a very large overlap, generative AI, what it's capable of, and what software developers do in a day-to-day. For example, 30% of all conversations on Claude, and this was in 2024 numbers, are related to computer and mathematical occupations. And also lower skilled software developers have a higher productivity gain than higher skilled software developers. These two studies, super cool. They were the release of GitHub Copilot in all of Microsoft and all of Accenture. So slowly they gave some people access to Copilot, some people not. And they found that the lower skilled developers benefited a lot more than the senior. Although it still helps seniors. Like I wouldn't say I'm senior, but I'm definitely not a beginner. And I use it all the time and I love using it. Okay. This is good, right? So yeah, she's happy. She's super happy that generative AI is making junior software developers more productive. Super thankful. But
Super side.
yeah, let's zoom out on the picture. And so this is the state of the junior software developer job market. And it's all because of generative AI making software engineers more productive. There are more causes as well. There's like a general market drop, but even for juniors, it's a more significant drop for juniors and seniors. And that's the purpose of this whole project. And we're going to prove that. We're going to prove that with real-time labor market data from this awesome company called Lightcast over their whole data set that we have access to, 440 million job postings from 50,000 sources dating all the way back to 2010. It's been super high profile applications like Northeastern with our 200,000 master's programs. They go to Lightcast, they look at what skills are in shortage, what skills are growing, and that's how they can determine what master's programs to build. And yeah, this list can be super, super long. How does it work? So a standard job posting, we have whatever qualifications, preferred, like they're saying 2 years of experience. That's what they're asking for in this case. So Lightcast will go grab the job posting and then scrape it and process it. It's going to look like this. Interesting for if you want a visual look at it. We got job title, posted date, and also a process list of required skills. Just like anything that's possible on a job posting, we can get that in this data form, and that's what we work with. Just quick validation. A bunch of studies have validated it. There could be some improvement with the validation methods, but like on average, it lines up pretty well with actual job vacancy data. JOLTS here is the Bureau of Labor Statistics report on job vacancies. So we look at the relative proportion of vacancies across industries in JOLTS and then across industries in Lightcast. And it lines up, I'd say, pretty well. Some like notable ones, leisure and hospitality, actual job vacancies are much higher than Lightcast reports. You can think like bartender, server, cleaner, those type of postings probably aren't going to be like you're not searching Indeed as much to find that opportunity. It's going to be more local based. And professional and business services are overrepresented by Lightcast. So it's a very computer heavy world, and that's what we would expect to see. Okay. And we're going to limit our sample a bit to 2019 to present day. Also, just looking at SOC 15. So this is all computer and mathematical occupations, 20 million of those, and also just software developer occupations. That's the SOC 6 category here, 5.7 million postings. So that's our data set that we'll work with. Let's define senior versus junior. So like if I say a software engineer versus a staff software engineer, staff is going to go regular software engineer, senior, and then maybe go to staff after that. So we'd expect staff to require more years of experience. That's what we see in the data. Good sanity check. It's almost not double. It's a big jump in the average years of requirements, how they're different. Other papers also can use education requirements or certification requirements to determine senior versus junior. It doesn't really work as well for software developers just because there's not a lot of variation in education. It's a lot of bachelor's degrees for the requirement, and only 16% of postings have certifications, and the majority of that is security clearance. So if we're trying to say senior versus junior skill, security clearance is not a good definition of what senior versus junior means. Average years of experience works fine for us. So we do senior as 4 or more years of experience and junior as 0 to 3 years of experience. But then some postings don't list experience, so that's just going to be null. We're going to say that's null or unlabeled. I'll use interchangeable words for that. Let's look at the ratio. So senior to junior vacancies, pretty constant. 2021, ChatGPT gets released, And it's just a massive spike, an unreasonable spike in the senior to junior ratio. It's almost on par with the spike from COVID, which is very scary if you're a junior software developer. The whole industry is declining, just the raw number of vacancies is declining right now. But this decline is much sharper and scarier. So if we look at the share of vacancies, break that apart, what's actually happening? It's not that seniors are spiking, it's that juniors are dropping. Juniors just, right, pretty constant, pretty stable line. ChatGPT gets released and it just plummets for some reason, probably from generative AI. That's what we're saying here. You can see there's something funky going on with the null versus senior. They're kind of inverted. And as a sanity check, we're just going to dive into the null postings right now to make sure that like it's not going to sway our results. So that's 35% of the postings in our sample. We just do a simple logistic regression, logistic classifier. So if it comes in, say it's a title, staff software engineer. Obviously, that's going to be a senior position. You're not going to see an entry-level staff software engineer. So we're going to toss that in the senior bin. And we just do this with all the unlabeled postings. And we get an accuracy of 74%, which is, I'd say, pretty good. Our margin of error, since we have so many samples here, our margin of error is pretty small. And this is what, just with the unlabeled postings, this is what we think the unlabeled world looks like. And we see the same pattern. Ratio of senior to junior, constant, spike right after ChatGPT gets released. So sanity has been checked, null postings are okay. And we don't really think about null postings for the rest of this talk. Probably some more work needs to be done looking into the null postings just in case. But for this talk, this is good enough to say like it's not going to sway our results. Okay, I'm going to get some water. All right. So now we got to do the causal evidence. Like, is it causal? And we're going to use difference and differences for our method here. This is the raw counts. So when I said the raw counts are declining across the board, this is what it actually looks like for the seniors and for the juniors. And I put the ratio on there so you can see that how the ratio is changing as well. Obviously, it looks like seniors has a higher absolute drop, but in this case, we're caring about the relative drop between the two, just because did one get impacted more than the other post ChatGPT? They're both hurting, but which one's hurting? I guess I can't say which one's hurting more because they're both hurting. Okay, so we're going to limit the difference in differences to just 1 year prior and 1 year post. And it's going to follow this equation. And I thought it'd be interesting. So rather than me explaining what the equation is going to do first, I'm just going to send this over to ChatGPT. And we can see if that explanation lines up. So screenshot, go over to here and say, I'm only going to care about the delta and the theta coefficients. So we'll say, can you interpret what different values of delta and theta mean? Okay, I'll let that load and I'll explain it to you and we'll see if it lines up. So obviously in the pre-period, the ratio is very different than the post-period. It doesn't follow the expected behavior. And we need to capture how much difference that actually happened, how much difference actually gets created in the post-period, post-ChatGPT being released in November 2022. We got this delta coefficient on senior right here. This is the overall difference between if you see a senior or you see a junior. And we're trying to predict a log number of vacancies here. So this is the overall difference across pre and post. But we need to account for some weird behavior happening with this ratio spiking in the post period. So that's what this term does, this interaction. So we're just looking at seniors in the post period and how much change can theta pick up. So that's just looking at the extra difference. So we got the delta right here, picking up the difference across everything. And then theta is accounting for what's different, what's changed. How much more do we need to accommodate? Let's interpret theta. I'm expecting ChatGPT to tell us this as well, so we'll see. If theta is 0, then seniors and juniors don't change at a different rate. They're going to be changing at the same rate. Is that the case in this picture? No. If theta is less than 0, then juniors' growth rate is more than seniors. So we're going to see the senior to junior ratio that should drop if theta is less than 0. So if it's dropping, theta will be less than 0. And if the juniors' growth rate is less than seniors, which is what we're seeing, then theta should be greater than 0. What do we see over here? Okay, yeah. Oh, cool. Delta measures the baseline difference in log vacancies. Yep, that's what we expect. Okay. A positive theta suggests that ChatGPT increased vacancies for senior roles more, and a negative theta suggests that ChatGPT decreased vacancies more for senior roles. Lines up with what we said. Thank goodness. That's always good to double check. Yeah, so that's what we're finding. So here are the answers to the quiz. So we run 6 different models looking at different fixed effects. And this term, this is our interaction right here. So this is theta. If theta is positive, then everything is as we expect. And across the board, across all 6 models, theta is positive and significant. Senior is also positive, which makes sense because senior level postings, oh, we're going the wrong way again. Senior level postings are above junior. So that's what we expect. Let's interpret at least what this theta would mean. So since our dependent variable is the log number of job vacancies with month fixed effects, we take E to that theta value to get 1.25. And from that, we can claim that junior vacancies contracted 25% more post ChatGPT relative to seniors, which that's a very large relative drop, a huge impact, which is what we would expect because ChatGPT is such a, and generative AI now with all the other options, it was like ChatGPT had 100 million users in the first 2 months. It's just everywhere. So we expect a massive effect like this. And is this effect applicable to anything besides software developers? It is, but not at the magnitude that we see for software developers. So in this case, we got SOX 15, all computer and mathematical occupations except software developers relative to software developers. And you know, it's got a little slope here, but then spikes really high right when ChatGPT gets released. So juniors within the software developer world were hit much harder than juniors in every other setting within the broader computer and mathematical occupations classification. Okay. Yeah, so we're in a bit of a pickle if you're a junior software developer. It's going to be harder to find a job. The number of CS grads has not slowed down. It's still like 100,000 each year. Ideally, it'll slow down just for juniors' sakes, but for our economy, that's like a very productive occupation to have. I want more software developers out there. So I don't know if it's a good thing to say it should slow down or not, but it definitely hasn't. That's beyond the scope of the paper. Probably more Alicia's domain to talk about. And also, out of work seniors could go down. Like if you're a senior with 5 years of employment and you get laid off or something, maybe you'll accept underemployment for a junior job. So the opportunities for juniors, if you have 0 to 3 years of experience, you're getting pretty squeezed right now. And that's a tough position to be in. So we make some recommendations using network methods for what juniors should do. So for each occupation, we get the most defining skills. And this is a method from Al Abdul Karim et al. 2018. They do a skill co-occurrence network, and we flip that and turn it into an occupation co-occurrence network. So we get each occupation's most defining skills, just to simplify it, because we don't need to care about communication. Everybody's got communication. Everybody's got teamwork. Those aren't important or interesting. We want super defining stuff like, I don't know, like NumPy vectorization or as niche, more niche. And then we calculate, after we get each occupation's defining skills, we calculate their similarity. This is almost the probability that 2 occupations share a skill. It's not quite the probability, but thinking about it like that is going to be very, very close to the ballpark of, yeah, the similarity measure with the probability. Oops. Okay. So in total, we only focus on junior occupations because our target audience is junior developers who probably are having a hard time getting work. That's 734 nodes, and it's a really dense network. It's not every single possible node that's connected, but it's really close, 260,000 edges. Here's what that distribution of edge weights look like. So pretty much all of these similarities are close to zero, which is not really useful. You're not going to go from software developer to vet tech. That's kind of a far off jump. So we're going to care about the ones that are on the tail end of the edge weight distribution, and that's only 0.58% that are greater than 0.2. And so if we zoom in, this might be a little small. In what occupations would I recommend a junior software developer transfer to? The similarity measure right here, that's this column, that's how everything is sorted. So we're going to look in computer occupations. This is all other. So this is kind of an exception. This is just kind of a throwaway where software developers probably were unlabeled and get tossed into this. So we're going to ignore that. But data scientists, database administrators, what we see is they're most similar to all the other occupations in SOC 15, with a couple exceptions. We show that it's close to management analyst. I would say industrial engineer might be a flaw in the method because that requires a lot of schooling, but the idea is there. Looking at vacancy change as well is important. So junior software developers, they've dropped 49% since the month before ChatGPT was released until I think I have this as 2 years difference. So October 2022 to October 2024, it was a 49% drop. And almost everything did not drop as much. So if you're a junior looking to be a little more competitive, find a little less like hard landscape to find a job in, pretty much every other occupation except for software quality assurance is going to be a better bet for you. Conclusions. So generative AI reduced entry-level software developer vacancies. We see that high experience roles are less affected. And then let's get into some policy. So policy might be encouraging entry-level opportunities for these people. You could think about like an inverted triangle is what's going to happen, like Japan's age distribution, how it's a lot of old people, not many young people. You're not getting that replacement. We're still going to need software developers, at least for the near future. I don't think they're going to get automated away. And if we discourage all juniors from entering into the occupation and don't have any training pipelines to get them to this senior position, there's going to be a skills gap that gets created. And when we want to build software products, we're not going to have the talent to build those software products. Also, some people are talking about, oh, give people more AI ML programs. That's what people need to learn in college because that's such a big topic. Actually, it's going to be, at least at this point, if you're looking to find a job, that's not a great idea. So juniors drop 49%, but if you look at junior level positions that also require an AI or machine learning skill, those have dropped 86%. So like on paper, it seems like, oh yeah, this is the hot topic. We should learn this. We should go into this. But it actually makes you more disadvantaged if you choose to go into that, at least right now. Hopefully, like in the long-term adjustment, which is one of our limitations, hopefully we see some recovery. We see things changing where like it's just a short-term reaction, and then we can recover and redesign the work that we have around a generative AI augmented developer. Also, we're studying vacancies in this case, not actual hires. So there's a chance that the actual hiring behavior could be completely uncorrelated, but likely it's not, but we need to account for that. And that's something I'll also put into the final paper once we get there. And I'm also really curious to look at where these displaced developers go, because they have been displaced. We know they've gone somewhere, and people have to have a job. And we can look at resume data sets to see, oh, the CS major didn't get work as a software developer right away. Where do they end up getting work? And we would expect to see those pathways of somebody's occupation look very different in the pre-ChatGPT world compared to the post-ChatGPT world. All right, quick recap. What did we learn today? We're doing great on time. Chapter 1, we showed how an AI teammate can improve performance using theory of mind. We can also create better AI teammates. Perceptions of agent teammates are complex. This is what we talk about in chapter 2. It's the combination of a bunch of factors that could interact and could cause unpredictable outcomes with perception, particularly voice type interacting with helpfulness for perceived humanness. That's what we show. And then chapter 3, AI definitely had a measurable impact on the labor market, and ChatGPT likely caused a 25% contraction in junior developer vacancies compared to senior vacancies. Finally, some acknowledgments. My awesome committee, former mentors that helped me get to this point, my parents, and also friends who showed up. Extra kudos. Yeah, thanks to everybody for helping me get to this point. I'm thankful and yeah, excited to see what comes next. Yeah.
Open up the floor to questions, just for some audience, any questions, and then we'll turn to the committee.
David.
Good to see you here, very happy with it's been doing. Have a question kind of related to the first two. So, in the human AI, in the first chapter, it seemed like it was a one-way thing, and it wasn't so much the same as in there was an interaction between humans and the AI. It was the AI was getting some information, and then they were using that. And then tying that to the second one, there was the perception that the robotic voice is more helpful than the human voice. So I wonder if there's like an expectation of like a confirmation bias, that if you're interacting with a machine, the machine has the right answer. So that they're more likely to do something like that, and they're more likely to engage with it in that way, similar to how you pull up ChatGPT and had it look at the formula. So I'm wondering if that kind of affects the idea of that human AI bond, if that's the assumption of the human going to the branch.
Yeah, so David's asking about how people's assumptions going into working with an AI will affect their interaction with it. Is that about right? And so it massively. So that's related to the Costa stuff where the computers are social actors paradigm, where just going into it, somebody's past experience, like say they really hate using Amazon Alexa and never gives them anything correct, then if they hear a voice that's similar to Alexa or in a similar tone, given in a similar style, like say they go to a Google Nest, they're going to bring that same like this thing is unreliable, it doesn't know whatever, doesn't know anything. Or instead, if I chat with the ChatGPT voice app thing all the time, and it's pretty smart, it sounds pretty human, then when that's going to create my expectations for future behavior of platforms that are designed and communicated in a similar way.
Do you think there's a way to mitigate something like that? And if you're thinking about humanness, how do you help the machine essentially, or have you thought about how the machine actually?
Yeah, I think exposure, like if we can get people to use it for long enough, if it's completely different than what their expectations are, that's kind of what we were able to show in the second one, where with exposure, we were able to overwrite whatever biases people came into it with. So that's why studying usability might be a really interesting topic, because how can we get them, even if they are biased against using a specific application or technology, how can we get them to use it long enough to overwrite those biases?
Hi, so I was wondering, so you have after ChatGPT was introduced, you have the lower vacancies for junior developers. But I'm wondering if you noticed any differences in skill requirements for the jobs that existed after ChatGPT was introduced.
The job vacancies that exist.
Yeah.
Yeah, so what we see, we go in, I didn't present on this, but we go in and look at is the distribution of job titles changing, or is the minimum years of experience changing for the distribution of all postings? And we see that they're not just hiring fewer juniors and just looking at, oh, we just want a bunch of staff software engineers now, and not hiring any junior level. Instead, everything is floating up with minimum years of experience. So everything, even juniors, all the way up to principal, is increasing in their years of experience requirements.
Yeah, but what about the skills itself? Like, like if your job posting, you have like, you need to know this technology, you need to know how to use this database.
Yeah, it's hard. It's hard to, so we can go in and pinpoint specific skills that are showing up. but it's hard to give a broad summary. Like the broad summary that people want to hear is that AI skills are going up. And we do see that. We see that the fraction of postings asking for AI skills is going up. Like generative AI as a skill pops up right after ChatGPT gets released, and it's a slow increase from there.
Into their class routine. Clear, you have no idea what this job entails. Clear credentials to today's
I think
level of
somebody's
learning.
talking.
You are right, because I just saw everything on the internet.
Yeah.
Maybe it's ChatGPT.
Research skills, other
I don't exactly know. I'll mute.
technologies you're given.
I just trying to mute this person.
Did you just kick them off?
I muted them. They didn't seem happy. Yeah, so I don't have a specific, like, I can't generally say. I haven't dove in well enough to generally say what categories of skills are floating up and floating down. But we can see that AI is spiking, but that's mostly led by AI in senior roles.
But we do see like for a lot of the things you see for any occupation, like problem solving, like things like that increase over time but that's also happening like across the whole economy, right? As we see that. But I think what makes it tricky to look at very specific skills for software developers or anything in the software industry is that there's so many different types of software. And so the way like CAS codes them, each one of those is a different type of skill. So they'll bundle them into like very like broad categories, right? Of like I don't know, give me an example.
There's a whole AI bubble that you can get
There's
from
that,
AI.
there's even like stuff like are you using SQL or something, or something like a database language, right?
Cloud.
Cloud computing is another one. But so it's either like these very broad things that you don't see movements in, or these super hyper specific ones where it's like, of course, like, there's only 25 postings that are asking for that thing. So like if you get a little bit of a change. So it's a little hard to pinpoint this data.
And that also reminds me that I looked at the senior to junior ratio for all of the top skills, and there are only 3 out of the 150 top skills that show an increase for juniors in the senior to junior ratio. Or I guess that's show a decrease in the senior to junior ratio. And it's problem solving, troubleshooting, and mathematics. Just like, and those seem like filter skills. It's not just being good at math makes you, like, they don't want more people who are good at math. I think that just helps filter out the lower level junior applications.
I think there has to be like macroeconomic changes like how do you think about those potential?
Looking at like what's different from 2012 to 2022.
Yeah.
Yeah, so we would think that the job market had accounted for all of those changes by the time we get to our specific period that we're caring about. Like COVID had a massive impact, and by narrowing the range that we're caring about, hopefully we're limiting ourselves from having to think about those. But there certainly are other effects that are incorporated with this. When I'm saying there's a 25% change in the rate after ChatGPT, there are other things that are involved that are changing this.
In general, like that idea of the difference in difference method, right? So we not only focus in on the period that's close to that change, but that's why we're looking at the relative change for juniors versus seniors, because you can see both of those lines are going down, right? So like even before this, right, we had this post-COVID where it's like, oh my God, we need everybody to be developing all sorts of software for us. We're in this like online world. And then the whole world reopened again. We're like, okay, we don't need to do any more. Like, we can sit down now. So that's one of the reasons, why we're comparing juniors to seniors over time, right? To be able to, pull out what's happening in general to the software industry versus what's happening specific around that.
Any other questions?
We think organizations encouraging multi-skilling against people who are not specifically skilled in these areas might have some influence on this one.
And
for example, sense. Tremendous AI training for everybody.
I guess by multi-skilling, you mean
Like,
being a software developer, but working in bio?
like people are software developers, but organizations encouraging them to get skills that
Uh,
might not be able to do the exact software development.
Yeah, I think it does give you an advantage. I'm not exactly sure how it would impact your chances in the job market, but I know like coming into this PhD program, some people knew how to code, some people didn't. And obviously the job description of the PhD student is not coding and data science. But if you do have that ability, then you get access to more opportunities and more choice. You have more paths to go down, which having more paths just would make you more competitive. So I would assume that the multi-skilling could be good unless you're going down unless you're trying to limit your options to go down a specific path that becomes more competitive.
I'm saying it's less job postings because there are more people in the organization who are being encouraged to upskill.
Oh, so existing employees. Um, yeah, I think that would have an impact if the company could do that on a large scale. But we do look at fixed effects for firm size. So even firms that are really, really small, um, they're a bit slower to show this spike, but after 2 years, they do get back and show the same disadvantages in the long term as larger firms that would have the opportunity to shift employees around internally. Yeah.
Great. Congratulations. I haven't seen this data set before, but I'm sort of really intrigued by like the natural timing of when companies hire senior versus junior employees. So like, is there a typical company hiring a software developer?
Yeah, so Brennan's question is about
Something else.
so you're asking, I guess you could.
Sort of two questions. One is like just in general, is there a lag? You hire junior first or senior first? And then if there's anything within firm to
I don't think we see, so Brennan's asking about if there's a lag between hiring senior versus junior, and then also within firm differences in their hiring behaviors. I don't think there's a specific lag that I have found. It's just it seems pretty random what they choose to do, what companies want to do versus like what vacancies we see, like month over month, I guess. Yeah, I'm not really sure about what you mean by the second question.
yeah.
But we can control for like the same firm over time and even the same job at the same firm. So like, it's not just that, I guess what I'm interpreting from your question was like, oh, is this because of, different firms hiring at different times kind of thing? Like, is there a change in the composition? And that's the shift share analysis that Sam alluded to, but didn't quite have enough time to present in this, where we look and we hold constant, who is hiring at the moment, and let them change their requirements for those positions. And then we do a counterfactual, or we hold steady the requirements for those positions, so we let change who is actually doing the hiring. And we find that most of this is happening from changing the requirements, not like a shift in the mix of firms who are hiring.
4:15, it's been an hour. So I think we have to move now. We kick everybody else out and then the committee
Do
grills.
we have a question on mine or no?
No, Rich was having a hard
Oh,
time
that's right.
hearing the other
Okay, good.
people, which makes sense. Yeah, so thanks everybody for coming and yeah, have a great rainy Monday.